Good afternoon to everybody, and thanks to Mauro and DPC for the invitation to come here. I'm a scientist. Most of us, many of us, are scientists, but we also have another life, I guess, and that's like a traveling evangelical preacher, because we've had the privilege to have some really valuable experiences at different volcanoes of the world, and it's almost it's our privilege and duty to share them. I noticed that Okada-san came here to share his experiences. I know that Gianni Macedonio is going to Japan in a few weeks to share some of his, and so on. It's a sort of a traveling band of preachers, if you will. Let me tell you the story about the build-up to Pinatubo in 1991 and the warnings that were given. And I need to set the stage a little bit. The stakes at Pinatubo were very, very high. It was a volcano that had not erupted for 500 years. People knew virtually nothing about it. There were more than 1 million people at risk around the volcano. There were 2 very large American military bases on either side of the volcano. Because the volcano had not erupted in living memory, the people had very little awareness of the dangers. In fact, there was tremendous skepticism. I can't state too strongly how much skepticism there was. People did not believe that Pinatubo was a volcano. People did not believe that it would erupt, and we were suspect. And it was suspect not just because we were scientists, but also because there were some other political issues going on, like the renegotiation for the bases. And each side in the renegotiation suspected that we might be trying to influence the outcome of that political debate, which actually we were trying to avoid. Here's a picture of Clark Air Base looking up toward Pinatubo in the background. I sketched in the pre-eruption outline. Actually, it was not quite as impressive as that. You could barely even recognize that it was a volcano. The reason it didn't look so much like a volcano is because it has a history of blowing itself apart. The uncertainties, the scientific uncertainties, were extremely high. There had been only a very small amount of mapping, so it was very limited knowledge of the eruptive history of Pinatubo. We had just a very few age dates. There was no prior monitoring of Pinatubo until 1991. And there was, I should also say that we could see from the geology that Pinatubo had a history of very big explosive eruptions, VEI 6 or maybe even 7. And yet there was no experience anywhere in the world about what the precursors to such an eruption would be. So this was a big uncertainty. Shortly after the volcano became restless, a group of us from USGS were invited by the late Ray Punangbayan, director of FEVOLCS, to come over and work with his team on trying to figure out what it was going to do. And one of the first things we did was to try to make a hazard map. And it was actually a tandem operation. Ray was working with aerial photographs and sketching out where he thought had been affected by pyroclastic flows, and then he would tell us, and we would go check in the field each day. And it worked very well, actually. We quickly drew this map. As you can see, it's not very professional looking, but I think it did the job. It showed the areas that would be subject to pyroclastic flows. We said that all of the river channels would be subject to lahars, and the entire map area would be subject to ashfall. On the monitoring front, FEVOLX initially had a temporary network, just a small network out on the northwest side of the volcano, and they found that earthquakes were occurring about 5 kilometers northwest of the summit. When we were able to put in a larger network, we found the same thing, that in fact most of the seismicity was occurring 5 kilometers northwest of the summit, and it wasn't until late May that seismicity actually started underneath the summit. This was the initial seismicity, and this is it here. The summit is here in cross-section, and these earthquakes right there didn't begin until late May. One of the challenges of working in this situation was to come up with some warning schemes or ways to convey the warnings that would be easily understandable. Remember, we're working with local officials and also military officers who have no familiarity at all with volcanoes. So we adopted a simple alert level scheme that you can see here, and when we adopted it in the middle of May, and right about that time we found that there was positive evidence for involvement of magma. That was our first measurement of sulfur dioxide SO2 emission, which at 500 tons a day was clear evidence that magma was driving the unrest. So we started at alert level 2 and went up from there. This is just a brief history of when the alert levels were declared and corresponding evacuations. The evacuations were not tied one-to-one to the alert levels, but it was roughly tied together. Again, when we first started the alert level, it was here, and it stayed here through the rest of May and into early June, and the activity was not increasing systematically. It was just going up and down and up and down. It was teasing us. It wasn't until early June, and specifically June 3, when it finally started to ramp up in a systematic way. And by June 5, it had ramped up enough that Ray issued the alert level 3, saying that an eruption was possible within 2 weeks. We did not say that an eruption would occur within 2 weeks. We did not say that an eruption would occur in exactly 2 weeks, but those were the kinds of interpretations that came in the newspapers. What we said was possible within 2 weeks, and then there were reinterpretations of that, particularly in the news media and by many of the local officials. So it had to be explained quite a bit. Accompanying this, there was recommendation for a renewed recommendation for evacuation out to 10 kilometers radius. Just 2 days later, the seismicity had increased more, and it got up to was raised to level 4, and then level 5 shortly after. I'll come to that in a few more minutes. What we were trying to do, and I think this is the goal of eruption forecasting anywhere, is to get it just right. You want to get your forecast just in time, not too early and not too late. And also you want to define your hazard area just right, not too big and not too small. And that's a difficult thing to do, but that's what we were aiming at. During this time, we were very acutely aware of two other volcanic crisis, one at Soufriere Guadalupe volcano in 1975 to 77. 76 was when the eruption began. It was a phreatic eruption. Magma almost erupted, but not quite. And the precautions were to evacuate the city of Basse-Terre of 70,000 people for 6 months. So that was actually a very disruptive time, and the scientists, there were lots of arguments between scientists, and it was very disruptive, a lot of criticism of the handling. In the overall picture, it turned out to be a false alarm, but it was nearly a magmatic eruption. In the case of Nevado del Ruiz, 85, I think you know the story. It was a magmatic eruption, not very big, but it melted snowpack and sent the lahars into our marrow that killed nearly 25,000 people. And it was a case, as has been mentioned earlier, a case of inadequate communication. We were trying everything we could think of to explain the volcanic hazard to local officials, to the military officers, et cetera. And one of the things that I thought might help, particularly with the military officers and civil defense, the head of civil defense at that time was an engineer. And we did an event tree. This is a very simple event tree starting at the left-hand side. By the time we did this on May 17th, we estimated it was already 100% chance that it was magmatic in origin. We estimated a 40% chance that the magma would actually erupt. When it did erupt, we estimated a 70% chance that it would be a very large eruption. That's a high number. Normally we cannot do that, but we did it in this case because the past history of the volcano seemed to be almost exclusively large eruptions. And then we estimated the probabilities of the pyroclastic flows, in this case, traveling out to 10, 15, 20 kilometers. And the edge of Clark Air Base was right here at 15 kilometers distance. So the probability of a pyroclastic flow coming onto Clark, at this time we estimated, was about 3% sometime during the coming months. That I should add, by the way, that when we presented this to the military officers, they really took notice of that. I thought they might just say, oh, it's a small percentage, but they did not. They said, wow, that's a really high percentage. Now, one of the other problems is just trying to explain the different hazards to people who are completely unfamiliar with them. And we had a blessing from one of the silver linings, you might say, from the Nevado del Ruiz disaster. Because after Nevado del Ruiz, a group of volcanologists got together and said, how can we prevent this from happening again? We knew that the people of our marrow did not understand the term flujo de lodo, mud flow. If they had understood it, they would have moved out of the way, but they did not. So we made a video, and the late Maurice Kraft was the prime mover on this, showing all of the major volcanic hazards. What is it? How fast does it travel? How far does it travel? And what does it do when it hits you? It's very blunt, and it was almost finished by the time of Pinatubo. We had a rough copy. We made many copies. We showed it to all of the officials, and it really helped tremendously. And in particular, there's one little section in there. It has a little girl trapped in the mud flow, and she's shaking. And every time we showed that, you would hear this gasp from the audience. It really helped a lot. The irony of this is that Maurice and Katja were killed at Unzen just a few days, well, it was on June 3rd, 1991, en route to Pinatubo. The earthquakes I showed just here in May, up through the end of May. There were a few deep long period earthquakes that were not recognized as such at the time. We knew that there were shallow long period earthquakes. We knew that there were a very few summit volcanotectonic earthquakes. Most of the earthquakes out to the northwest are not shown on this graph. And one thing we did know is that from the first measurement of SO2 up until the end of May, it increased tenfold, from 500 tons a day to 5,000 tons a day. So we interpreted that as evidence that magma was rising. Now, this is an interesting lesson, and I understand one of the speakers this morning made a similar point. This is the location of our first observatory. It was in an apartment. The volcano is up here on the left. And this is near the center of the air base. And we said to the officers, to the commander of the base, we said, you know, we're a little bit nervous staying here in this place, and we'd like to have a fallback observatory. First, we asked if we could use the control tower, which is right here on the runway. And I don't know if you can imagine, but this is like air traffic control central, and it's almost like blasphemy. It's unimaginable that they would give that up to scientists. So then we asked for a little building that was way out here at the far end of Clark Air Base, 5 kilometers farther away. And when it got too nervous for us, we moved from here out to there. And you can imagine this has a very strong message for all the military officials. They moved too. Okay. The activity did begin to pick up in early June. I won't go into it in detail here, but especially we were seeing more of these shallow, long period earthquakes. And this shows the alert levels graphically against time. First, we declared the magmatic eruption without any particular time frame on it. This was the eruption likely or possible within 2 weeks. This was eruption possible within 24 hours, issued on June 7th, and indeed a dome did start to grow on the same day. And on the 9th, there was a sighting of an ash cloud similar to one that Okada-san showed earlier coming across Toyoko. It was the relatively cold pyroclastic surge, but it was enough to trigger the declaration of the eruption in progress, the highest alert level. In some ways, it was a little bit premature, but it was actually very good that it was declared at that time, because what we discovered is many people were waiting until the highest level of alert was declared. They were not evacuating at level 3 or level 4. They waited until the highest alert was declared. I mentioned skepticism. There was a lot, and especially in the days right after the Americans evacuated the base. But you know, it doesn't matter. What's really important to understand is that you must expect a lot of skepticism at a volcano that has not erupted for a long time. We did update the probability tree on June 10, coming up with an 8% chance of it hitting Clark in the near future. But this was almost a moot point by this time. It was not used by the authorities because the evacuation had already started in large scale. And just 2 days later, on June 12th, the explosive eruptions began. This looks like a big eruption. It looks like an atomic bomb. It's actually not so big. It's a VEI-3 eruption, and there were many of these between June 12 and June 15. Here's June 12th over here, and June 15. These spikes are the VEI3 eruptions with the column height in kilometers. So that's about 18 kilometers, this is about 25 kilometers, 24, etc. And you can see that they got more and more frequent over here on the late 14th and 15th, and at the same time, the seismic energy release, particularly from shallow, long period earthquakes, was increasing sharply. That's this curve here. This was really dramatic, and I think it's the only part of the monitoring data that was truly diagnostic that we were about to have a VEI6 eruption. All of the rest of the precursory unrest before this was very ordinary. It could have been for a VEI2, VEI3, nothing special. This is the only part that was really special. And what you can imagine here is that what's happened is the magma has already erupted here. It's cleaning out the vent. It's bringing more and more gas-rich magma up close to the surface, and it's starting to become a runaway reaction. And that's what this is here, leading up to the climax on June 15th. There are very few pictures of the eruption, of the climactic eruption. This is taken from space. This is the outline of Luzon here. Pinatubo is there. Manila is there, about 100 kilometers between them. The diameter of the umbrella cloud is 500 kilometers. Everywhere underneath the 500 kilometer umbrella cloud is completely dark, even in the middle of the day. So let's take a quick look at the reach of the pyroclastic flows compared to the hazard map. The hazard map is the dotted line, okay, and the solid line is the actual reach of pyroclastic flows during the climactic eruption. It's not 100% perfect, but it worked pretty well. In summary of those who were at risk, killed and saved, I mentioned the roughly 1 million at risk. That included 20,000 indigenous Aita people who lived on the volcano, and that area was completely devastated by the eruption. Most of them, almost all of them, escaped. There were 85,000 evacuees before the climactic eruption and about 250,000 just after it. Unfortunately, there were some deaths. About 400 died during the eruption. There were 500, this is really the sad part, 500 Aita children died from measles in the evacuation camp. The reason is their parents did not trust Western trained doctors, the doctors from the lowland Philippines. They didn't trust normal pharmaceuticals. They wanted to use their natural herbs and plants for healing, but they couldn't reach them because they were up on the volcano. So a large number of children died. On the other hand, there were many thousands of lives and a lot of money saved by these early warnings. And now, I guess I do want to just make a few other points. After all of this, I guess those of us who worked on it had very mixed feelings. We were happy that so much had been saved, so many people had been saved. We were really agonizing over the deaths that had occurred. And then I had a colleague who came to me and said, "You guys were just lucky in your forecast. You know, that wasn't skill, that was just luck." And my first reaction was to say, that's not true. And then I thought, well, there is some truth in it. And it is true that we had some lucky breaks from the volcano. During that period of 1 to 15 June, where it ramped up pretty systematically, That's relatively short. It's an easy time frame to manage, and it was also systematic, and it didn't drop off and give a false alarm. So that part was lucky, and also you saw the first explosive eruption. That was enough proof for everybody that there was a problem. The eruptive history at Pinatubo had suggested that all of the eruptions were big. Now, we know now that that's not true, but at the time, that's what we knew. And so we didn't have to deal with the problem of, is it going to be a big eruption or is it going to be a small eruption, which is what Carmen asked a little while ago. We just said, if it erupts, it's going to be big. And so that was lucky. But I also have to admit that we drew the hazard map for what we thought was the worst case scenario. After the fact, we realized we underestimated the worst case scenario. If the real worst case scenario had occurred, it would have been much, much worse. There would have been a lot of deaths, but fortunately it didn't. The Pinatubo 1991 eruption was one of the smaller eruptions of Pinatubo. But we didn't know that at the time. And the last point I would say that was very important in the, you call it luck, but the civil defense was very responsive. We had a good partnership. Ray Puddingbein had built that up over the years with civil defense. Now, so what I would say is it was not just luck. There was luck, yes. But we also followed a number of necessary steps. We did all the things that you have to do. It was, work out the eruptive history and the scenarios, the hazard map, put in the new monitoring quickly, interpret it right, and then there was urgent public education of the officials and the public, and especially with the video. There was a quick international response that I think helped. And then I'd say that Ray did a marvelous job of managing the whole crisis and dealing with the various officials and with the news media. And I also have to give him credit for putting his neck on the line to warn of what we thought was a worst case. I think many of us might have been hesitant to do that or afraid to do that. Ray did not. He went ahead and put his neck on the line for that. So the bottom line that I'd like to convey is that in order to succeed in managing or succeed in a forecast and crisis like this, you need to do all of the necessary steps. And then it helps to have some luck on top of that. Okay, thank you.